This video will take a look at the parabola parent graph. As you can see on the left side, we have all of our key features that we should be able to recognize when you see a parabola graphed, and you should be able to use those information to make some decisions about what can happen in that particular graph. We're going to be using the Desmos grapher to help us take a look at what happens as we shift things around. First off and foremost, what we have is the locator point, which is the point HK, as it will be for all of our points. And what we care about here is what that represents for us, and that's going to represent what we call the vertex. So the vertex of that parabola is at this point HK. Now, the graphing form is what happens when you have your stretch factor and the shift left and shift right. So the graphing form is always going to be in the form A times, in parentheses, x minus h, all squared, and then plus k. The x minus h is because you're looking at the difference, the change in x in those particular points. Now the domain for this has to do with the fact that this is your y equals x squared equation. And since you can square every number, your domain is going to be all reals. So all real x values are able to work. You could, of course, say negative infinity is less than x, which is less than positive infinity. Now the range is a little bit different because in this range, that is determined by what's going on in your particular graph. So if I were to shift my HK around, you can see that the range, the possible y values, is going to change based upon where that k value is. So to generalize it, the range is always going to be y is greater than or equal to k if a is greater than 0. If a is less than 0, then what happens is as I shift this a value down, you can see that the range of it all shifts down as well. So let's take a look at a, h, and k. You can see them on the side here as we move those values around. So if I shift a up, you can see how a changes to be positive. This is a vertical stretch, and I can bring a back down to 1. As I drag my hk around, you can see how those h and k values on the left side also change. So if a is less than 0, for example, then that would mean that your range would instead be y is less than or equal to k. Now, a parabola does have a line of symmetry. That line of symmetry is going to be right through this vertex. Because see what happens on the left side of this point also happens on the right. And so the line of symmetry, we want to write that as a line. So that is going to be an x value because it's a vertical line. So it's always going to be wherever x equals h is. Now an asymptote is what sort of point or what sort of value your graph gets closer to as x gets big or small. Now there is no one consistent y value that this graph is getting closer to. So for a parabola, there is no asymptote. So again, you can go to this website, you can go to this link, and you can kind of play with it yourself. But the key thing is noticing how when you shift your h and k around and you stretch your a down and left, you can come up with what that a value is. Now what you have in green here is that your a value is always going to be equal to the height of this line when you move 1 unit to the right of your locator point or vertex in this scenario. Finally, you will be asked to write a lot of this work into Moodle. So the syntax would be what sort of format that should look like since we kind of write it all on one line and we don't have exponents. So the Moodle syntax is going to be y equals a. You should use parentheses, x minus h, group that stuff together, and then you will do to the second power with the caret symbol, and then just write plus k afterwards. You don't need any more parentheses than that. Just the parentheses around that inside part, because that's the only part that gets grouped together. So this is how you can set up each of these important parts and key features of any parabola graph.